Okay, so I'm just getting this up and running. Screen. I only have to finish one thing today. And then if there's any discussion stuff that we didn't finish last time, did you finish the approximate area with the summation stuff? I can look. There's one for each group. There's the area, that's a picture. Okay. Oh, I guess there's more here. Oh, yeah, you did this. So this right here, the capital F, that's the fundamental theorem of calculus. Evaluated in 25 and 5. Boom. And then this is using 3,000 rectangles to approximate and get the same sort of answer. Pretty close. Okay. And then what I said was, if you have more people in your group than you might, you could change the number of rectangles, have another producer produce it with more rectangles. Or did I have a better idea than more rectangles? I have just change the number of rectangles. Actually, I'd like that. If within your group, you had one group do 3,000 rectangles like Sarah did, and another one do 30,000 rectangles, then that would show you that the answer is closer if you use more rectangles. Okay, where am I? Back to here. All right. So the last thing I have to do is go over what happened. So last time we went over the whole concept of substitution. Substitution undoes the chain rule. Okay, so when you take the derivative, so this one right here, for example, that we did last time, when I do the antiderivative, I get this answer, but I just want you to see where's the answer. Here's the answer right here. So if I take that's 3/2, so that would be the same as, let me see, 3 and okay, so if you had something like this and you had to take the derivative of it, that was not good. If you were asked to take the derivative of that, right? You would use the chain rule. Right? You would take the derivative of the outside power. So what would the derivative of the outside power be? You'd have the 2/27ths, and you bring it 3 over times 3 over 2. And then the power you would have raised to 2 is to the 1/2 power, right? And then what do you do with the inside stuff? Chain rule. You leave it alone, yes? So that would be x raised to the 9th plus 8. And then with the chain rule, then you take the derivative of that. So you do times the derivative, which is 9x raised to the 8. Okay? All of these numbers combine and do whatever it is that they do. I don't know. There's 2 to just 9. So all of them go away, actually. That 9 and all of these go away. So you end up just with what you started with, which is x to the 8th times the square root of all of that. But again, the important thing to note is that x to the 9th, that was the thing that was left alone. And that's how we are able to undo it, the chain rule. We say, okay, since that was what was left alone, we'll put that in there, and then all the numbers are the things we have to worry about. Okay? All right. I didn't really want to do any more of those substitutions unless you have questions on them, because I can answer them next time if you have questions on substitutions. But let's just look at them. Here's a cosine on the inside. So the derivative of cosine is sine. So this sine of x dx, that's part of the chain rule that just came out. That sine of x isn't part of the problem. It was inside. It's the derivative of the inside function. This minus and the cosecant squared, that's coming from the cotangent. So the cotangent is the inside function and everything else is just crap that came out. Okay, this one's a little different. This one's one of those antiderivatives. This is one of those inverse somethings. So I'd have to look it up. So let's just pretend we're doing this on our own and I don't know what it is. So I'll do it this way. So let's say derivatives of inverse trig functions. Okay. So when I look at this, they're all kind of small. Let me find a big one. I think this. Okay, do you see this bottom one right here? Actually, that's not the derivative, that's the antiderivative. You see how there's a u and then a u squared and an a squared. So this would be the u. So I could say u equals x raised to the 7th. In which case, what's du going to be? What's du going to be? 7x to the 6th dx. Okay, so in our problem, just copy it. That's the original problem. Okay, so 7x to the 6th. If I just put let me cut that out. I'm just rearranging it algebraically. That 7x to the 6th right there, that's all going to be replaced with du. And this right here is x to the 14th power is just x to the 7th power, what, squared? Okay. So now when I replace that, this whole thing is going to be u squared. Squared. This here is going to be u. And this is all going to be du. And that is exactly, now I can just copy it down here. It's the arc sine of the absolute value of u. So this is just equal to the, not arc sine, it's arc secant. So it's a secant raised to the -1 of u plus c. Everybody wants to come. Okay. All right, so this is just, so anyway, you can't leave it that way. What do you have to do? You have to replace that u back with what? X raised to the 7. Now, there are some things you have to know about this. I was kind of sloppy. Absolute value is an issue because that's x to the 7th. If x to the 7th could be a negative number. If it was x to the 6th, you wouldn't have to worry about it. It would be positive all the time. So your answer may have an absolute value in it. I'm going to let you worry about that. But don't worry, that's never going to be on a test. But if that's just one of those concerns. I'm trying to think how you could check it with Desmos. You could definitely check it with Desmos. Here's how you could check it with Desmos if you want. You can take everything on the inside like that, copy. You can do y equals, that's all the stuff on the inside. Let me just blow it up this way. So that's the inside function. And so the derivative of what we get should be equal to the inside function. So let's just see if that's the case. Y equals t dx of that function. Okay. Now Desmos should graph that. Why aren't you graphing it? Use parentheses on the argument secret. Oh, I'm sorry. Okay, so do you see how the green is the same as the purple? So I know that this is the answer to that. Now, if I don't have the absolute value in there, it's not the same answer. Does everyone see that? See how it's not the same answer? It has a different thing going on. Okay. But when we looked at the formula did say there was supposed to be an absolute value there. That's what it called for. So I was being sloppy by not putting it in the formula. So that has to be in the answer. Absolute value. Everybody's happy. Okay. All right. That's one way you could get Desmos to check it. If you're not sure about those, whether or not the absolute value is necessary, well, it was. Okay. Where are we? Still here. So let me just start off. So today's lecture is about substitution with a definite integral. So what are the two types of integrals? Definite and indefinite. And an indefinite integral tells you what? The not derivative, but the opposite, the antiderivative. So the indefinite integral tells you the antiderivative. The definite integral tells you what? Area. There you go. Area under the curve. So this integral here is just telling you the area under the curve. And so therefore, Desmos will just do it for you. Let's put a period in there. There's a poop, the answer is 0. All right. I don't have to do a substitution. But if I do a substitution, okay, so if I do a substitution, let me just do it. Let me just show you what has to be done to do a substitution with the definite integral. Okay, what should our u be? If this is, we're going to use u substitution. U has to equal what here? What's inside the parentheses? Inside. X squared plus 4. So we'll start with that. Okay, if that's the case, then what's du equal to? The derivative of that. That's a dx. Okay, fine. So I'm going to take my original problem here. And I'm going to go like this, and I'm going to put a u there. Oh, x, if this isn't, I don't have x dx. I have x dx, but it's 2x dx. So I'm going to take that 2 to the other side, if you don't mind. And do it this way, divide by 2. Everyone okay with that? I moved the 2 over because I have x dx. So now I can replace the dx dx with du over 2. Du over 2, or I can just take the 1/2 out with that. Put the 1/2 up here. Okay. All right. Well, this one, it doesn't seem to matter. It's still giving me the right answer, although honestly, I don't know why. It's still giving me 0 as an answer, but you're not supposed to leave these limits of integration. When you do the limits of integration, it's the area under the curve between x values. This is x equals -5 and x equals 5. Those are the limits of integration, and they're on the x-axis. When you do a substitution, you're in u world. That's another world altogether. And so you can't, it's not the same u values. It's not u equals, it's u of. What's u of -5? Does anyone know? You plug -5 in for u. U is just to square the number and add 4. So what's 5 squared plus 4? 29. And then we do the same thing up here. We do u 5 squared plus 4. So you can get the same number, 29. Okay, so that integral. We should take the u ups out because it can't do it that way. That's going to be 0. If you integrate anything from the same number, it's going to be 0. Okay, the area under a point is 0 because there's no area. Okay. So, all right, so number 7, is that a definite integral or an indefinite integral? It's indefinite, so it's one of those antiderivatives. So, and then what do you think would be a good substitution? Does anyone recognize this as anything? Okay, so this right here is, let me just copy this down. You see that guy right there, e to the 6x? Can I write it that way? Can I write it e to the 6x squared? You see that? And now, if I take the derivative, if I just let u equal e to the 6x, what's du going to be? The derivative of 6e raised to the derivative of e to the x is e to the x. This is e to the u, so it'll be 6x will stay up there, but it'll be times what? Chain rule, you have to take the derivative of 6x, and what do you get? 6. Nope. Okay, so there's 6x. I just need to get rid of that 6, so I'll divide both. I'll take that 6 to the other side. So du over 6 is equal to all this. Yes, you have a question at home? No? Who is it? Anusha Suhave Mahir. Okay. So look what I can do here. I can do a substitution. I can make this, all of that, I can change to be u squared. U squared. Okay, and then e to the 6x dx, that's all just going to be du. Right? The question is, what is that? And if you were watching, do you see it on this list here anywhere? How about this one? Do you see it on this list? Anything that looks like this, that you take the derivative and you get 1 over the square root of 1 minus u squared. I think it's the first one, inverse sine. It's 1 over the square root of 1 minus x squared. This is literally the inverse sine of u plus c. And there's no, I don't see any absolute values or anything. So that's it. So anyway, that's what you're supposed to do. And then you have to replace the u with the you have to go back and finish this. So what do you have to do last? I have to put the e to the 6x back in. U. That's the final answer. That's what it is. All right, back to definite integrals. This one, I could do a substitution. First of all, if I just take the period out, I'll get the answer. It's 6.25. Okay, fine. It's 5/8. Now let's do the do it using substitution. Okay. I'm gonna let that part right there be U. So U equals this. What's du equal to? 2x dx. Now, I have a 10x. How can I get 10x dx? Can I just multiply both of these by 5 and I get 10x dx? Let's do that. So now let's look at this integral again. Down here and start replacing things. 10x dx is going to be just 5 du. 5 du. And this right here is just going to be u squared. Okay. 5 can come out. So put that up fine. Okay, but now can I leave the 0 and the 2 here? Those are x values. So how do I change them to y values? I have to do u of 0 and u of 2. What is u of 0 equal to? Plug 0 into the equation for u. That's substitution, right? So what's u of 0 equal to? Thank you. So that's 4 on the bottom. What is it on the top? 8. That's u raised to the minus 2 du. Now I can use I can do, what's the antiderivative against fundamental theorem I'm going to use? So raise u is to the minus 2. When I do the antiderivative, I get u to the what power? U raised to add 1 to negative 2. What do you get? Negative 1. And then you have to divide it by negative 1. Okay. And you have to do it at x equals top one, which is 2. And then you have to subtract the bottom one. That's not good. Oh, it's not 2 and 0. What did I do wrong? I changed it. If I do 2 and 0, what do I get? I'll get a number there, but when I put 0 to the negative 1, what is 0 to the negative 1? Undefined. I know I have an answer of 0.625. Because what did I do wrong? I put in the 0 and the 2, but I changed them to 4 and 8. If I don't do, I have x equals 2, but I have u equals 8. And then I have u equals 4. Okay, if I don't do it that way, if I don't change those limits of integration, in this case, I'll get undefined. So now what's the answer going to be? So I'm going to get minus 5 times, what is that? 8 to the negative 1? 8 raised to the negative 1 minus, that's going to be plus 5. 4.
Sir, can you move it?
It's to the negative 1. Excuse me?
Yes, me a little bit. Can you open this door? I think I left something behind there.
No, wait back. Tell me what that is. What? Okay. Shut that. Okay. It's 5 times 4 raised to the negative 1. Anyone? Yes, you didn't even have to do it because you know what the answer was. Right there. I'm proud of you. If you didn't do it, I'm impressed. If you did it, thank you for doing it. But you didn't have to because it's right there. Okay. Please note, as I said, with these problems, you don't have to do the whole substitution thing because Desmos will just do it for you. But if you do the substitution thing, if you have to do the substitution thing, you can't leave the 0 and the 2. You have to change it. You have to plug those numbers into the U. And there is a problem where you have to do that, like this one right here. So for this problem, they don't tell you what the function is. So you can't just put it in Desmos. Okay, so what you have to do a substitution. They tell you the substitution, U equals x to the 5th. What's du if x equals u to the 5th? Anyone? What's du? 5x to the 4 times what? Dx. Okay, so I have an x to the 4 dx. I do. So let me just move that over here so you can see it. So I have an x to the 4th dx, and that's what I have. So what can I do? I don't want that 5. So let me just divide it out. Put it over here. Okay, so now I'm going to replace all of this with du over 5. Okay, so this is going to be equal to, it's down, integral. So this will be du over 5. Du over 5. Okay, you know what? I'll just take that 1/5 out. Now I don't want it there. Okay, x to the 5th is just what? Isn't that just u? Am I done? There's nothing I can do if they don't give you the function. I'm done, except for one thing. What did I forget to do? And I said you have to change it if. What do I have to change? The what? I have to change these. Okay. So what is u of 0 here? I'm waiting. I'm not going to tell you. Yes, it's 0. What about u of 2? What's that? Two to the 5th. What is 2 to the 5th? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, maybe? You know you have Desmos right here. You could just do it. 2 raised to the... But you don't even have to do it. You know what? You don't have to. Just do this right here. Copy this down. And you want u of 2, you just plug the 2 in there. There it is, 32. Okay. Anyway, this is one of the few times you actually have to remember to do that. And by the way, don't be surprised if it's one of the few things that show up on the test, because it does sort of show up on the test. It's the only thing I have to test you on this, because if I give you one of these like this, you're just going to plug it in Desmos skin answer. So this particular problem is one of the 2 problems that I like to ask. And it isn't that hard, because all they're asking you for is what the limit of integration is. The upper and lower limits. Okay. This one here, this one is probably one that you can just get it to do. Oh, no, it won't. Oh, you can't do it because there's another F up in here. So this is another one of those, just like the other one. So I wanted that. So I'm going to replace this, except they're telling you sine is u. What's the derivative? What's the different? Oh, what's the derivative of sine? What's the differential? If u equals sine, du equals cosine x dx. So that's going to be, all of that's going to be du. That 5 is just some old number. That's going to come out front. Okay, so I've got all of this set up, except I have to do what to finish it? I have to do what? The limits of integration I have to change to what? U of 0 and U of, so what is that? What is U of 0? You think so? You sure? You plug 0 into where? Where's that 0 going into? The sign? What's the sign of 0? It is 0. U of 0 is 0. So what's U of pi over 6? I don't know. I used to know. It's a half, but I want to put it in here anyway. It's a half. Okay. Or the square root of 3 over 2.
So,
Yes. You know what that's going to get me in the retirement village? Nothing. Nothing. What? I told you I hate the circle. And I learned this quote. This is what. Now we're going to talk about retirement for a second. I remember learning this trick in high school that I thought was so cool. And then when I got to college and I used that, when I started teaching pre-calculus in college, I started using that unit circle thing. And it was so cool. And all the students loved me because I knew this trick. And then Desmos came, actually Desmos Scrapping Calculator came around first. And Desmos came around, and then it was like, why the hell am I teaching this stupid unit circle stuff? I never used it outside of a stupid math class. Stupid math class. All math classes are wonderful, but at the time, they were using that unit circle thing. And those special angles, there's like 5 special angles. There's an infinite number of angles that aren't special. And the only reason they were special is because back in the day, we didn't have a computer that could do this stuff in our pockets at all times. So all the math problems had to be like pi over 6 and stuff. And I hate myself for even asking this question. I should start just ripping them out. Pi over 6. Pooh. Give me a number like 15 or a real 1.5. I like the project stuff that we do because that's the sort of stuff that I saw in the real world. If I was doing anything, did I shut that door and lock it? Let's let people in, but then I'll get in trouble. Thanks for class in there. Usually. So did you check the loss about the security bank desk, the welcome centers ready to have it? Screenshot take one. So. Unit circle, eight unit circle, never want to see it again. There's a what? Unit circle club? No, I'm just telling you, I remember my students about 10 years ago, they used to say, will you include the unit circle test? And I was like, sure. And then I was like, no, not even going to ask unit circle questions. There's a song for unit circle. It just gives you the false impression. Again, it was nice when all we had were those special angles, but then it gives you the impression that you can't do anything but special angles. And life is not just those special angles. All right, let me take a look at what sort of questions you'll have on the quiz. So the quiz is due next week, right? Quiz 10 is due. So once you're done at midnight, if I'm in a good mood, I'm seriously thinking about opening up all the quizzes. No, I'm going to finalize your quiz grade. So not giving you any credit for the late quizzes, but I think I'm gonna open them all up. So if you want to study from them, because I think the quizzes are the best. Somebody asked me what's the best way to study. They fell behind and they missed a few quizzes. I'm like, that's too bad because those quizzes are the best way to study. So I think I'm gonna open them up. But I'm not gonna give you necessarily credit for them. Because bad things happen to when I do that, but maybe I will, I don't know. But I'm gonna open them up. And that way you can study from them. What do you think? Would that be nice or not nice? All right, let's take a look at this, but I'm not gonna do anything until quiz 10 is done. All right. If u equals the sine of x, we just had this, u equals the sine of x. What is the differential? Cosine x dx. Don't forget the dx. Because if that were a verbal problem and you just said cosine, you'd lose points for not saying the dx. All right, fine. Do we know the other ones? Integration by substitution, parentheses, exponents. Remember, parentheses, exponents, and denominators, those are the ones that you look for to make the substitution. U is the letter you use. U of A and U of B are the limits. For this A and B, remember that thing I just emphasized, you're going to use the limits, U of A, U of B. Okay. Let's try this one. Say that. Who would like to say that? You've been saying too much. Okay, go ahead, say it. Derivative of f dx. Is it one of these? Q equals A. Q equals f of x, du equals f prime. This was before I had better notation. But yes, that's it. All right, 3. Click on the arrow. So lines, this is just line 14. Okay, we can look at these back substitution, integration by substitution, substitution on a definite integral. None of these. Finding the differential in the substitution. Only the substitution part in integration. This seems like it's going to be tricky. 14. It's one line too. Oh, there's 2 lines. What did they do here? So there's the integral. There's what they're going to substitute, right? So that's given. What did they do? Substitute. No. They ignored the integral entirely and just went with the u. And they did the du is what? That's a differential. Just the differential. And this right here is just the, so they're just doing that thing before they go back and substitute. They're just doing the differential. So wasn't that one of our choices? Finding the differential in a substitution. Okay. We're good at that. Do you want me to look at any other ones now? Let's see what the next one is. Okay, you want to look at the other ones first? Okay, so this one I'm doing just the substitution. I'm not doing any integrals. No integral. You see what happened? I had the u. And I figure out what du is, and then I get to this. That's a substitution. That's just algebra with the substitution, but I haven't done any substituting. I haven't done any integration, so this is just substitution. This one here, I did everything. It looks like I did the whole substitution and got the answer. So I had an integral, I did a substitution, I replaced everything, got the answer. So this is a complete. And this is a definite integral. This is a definite integral with substitution. So I think that was one of our choices. No, I can't go back. Definite integral with substitutions. I definitely that. This one here is another definite integral with the substitution. But the integral's never done. Look, the integral's still there. There's no answer. It's like integral, 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 integral. So it's the integration was not done. So the only thing that was done was the substitution. And the limits were changed. So this is getting ready to do a definite integral with substitution, but no integration was done. Here's Again, this one's a U substitution, the U substitution, where this is another definite integral with limits, but nothing, no integration was done. This is just finding the differential. This one's finding the differential. This one's. This one, you're given an integral and you're finding the differential. They just didn't give you U that time. This one right here, the integration is done. This is just integration by substitution. That's not a definite integral, but the whole thing's done. So they did all of this. And then the last part was integration by substitution. Actually, this is just integral. The back sub, oh, so this is all done. That's all been done. The last step is just to do the back substitution to replace the U with the cosine. Tricky. This one here, integral equals, so now the integration has been done. Okay. This one here is all set up, and then it's integration. This is another integration by substitution. This right here, there's the substitution. That step is just integration. And back substitution. All right. Okay. Fill in the blanks. Oh, look at this. This is exactly what I was afraid of. Okay. What does this become? So I'm just getting this. That was the whole time. Okay, so tell me what I do. I have, what did they do here? What's going on? You're saying I have an integral, that's a definite integral with some stuff, and there's a lot of x's, and then it says change it into another integral with a bunch of u's. But then it's saying, what are A, B, and C? So did they tell you what? This is obviously a substitution, right? There was x's before, now there's u's. Do you know what the u is? It is, because that's what's inside the parentheses. So u must be cosine. And du would be what then? If u is cosine, what's du? All right. U equals cosine of x. What does du equal? No. Negative sine of x dx. So I'm looking at my problem. I have a -3. So the negative is being used in the differential. The sign used in the differential. Everything here is used except the number 3. So what's going to come out for the letter A? The number 3. Okay. Let me write this integral down so you see it. Actually, it's already written down, right? First one that I just had. It's right here. Here it is. This is the problem right here. I just didn't want to. For a quiz, I have to make it a multiple choice. So that's the problem. Oh, hold on. This is a 3. And this is 3 pi over 2. And this one's 2 pi. Okay. And there's a minus in there, right? Minus 3. And this is a sine. This is a cosine. So this is the problem that we have. Okay. And we let u equal cosine. So that's going to make this. This is going to be u. The minus and the sine and the dx are going to be du. Okay. The 3 we do what with? Take it outside. Okay. So now what do I put for these two sides here? Do I put 3 pi over 2 and 2 pi? Or do I put something else? I put something else. What's u here? U is cosine, so it's going to be, just put it down here. It's going to be cosine of what? Cosine of what? 3 pi over 2. And what's it going to be at the top then? Cosine what? Okay, so what are those things? I'll just ask Desmos. So that's 1. This is 1. And what's the cosine of 3 pi over 2? That's 0. Okay, so now can we go back to the problem and answer the questions? So A is 3, B is what? That's the number on the bottom, which is the number on the bottom. What is it? 0. And what's the number on the top? 1. Okay. So last problem is a presentation problem. All right. Oh, so this one's one of my favorites because it's really hard. So pay attention. This is the number of calculus graduates there are. And the data is they want to count it each month. Okay. So they're counting as if, so they have this curve and it tells you how many graduates there are each month. So you're going to use little rectangles each month. Figure out how many graduates are, and you're going to do that for, so each month is 12 times a year. So you're going to go between 2010, after 2010, 10 years after 2010. So let's just write this down on our decimal sheet. I really like this question too, because it's tricky, but not hard. Use the regression to approximate the area under the curve. So I need the area. Look, all the formulas are here. But I have to go between 2010 and 10 years later. So what is 2010? So I'm going to start at 2010 and I'm going to end at 2020. And how many times a year am I doing it? So it's 10 years times 12. So the number of rectangles I want to do is 120. I'm doing 12 months here. I'm just adding up 120 rectangles. And that even says right there, n equals 20 times 12. Right? That's wrong, though. 10 years is 10 times 12. Oops. My bad. That's terrible. I have to fix that. I'm going to give a different answer. Anyway, so the answer is just, so if you want to know how many there were, it's that number right there, 5815.9. But let's see. That's the answer what it should be, 58159. If it's wrong, then I have to fix it. 5816, maybe. All students, yes. Okay, if I'm wrong, it should have been 240. What would have the answer been at 240? Oh, another bunch more students. Let's see. Okay. No. So the answer was right. The instructions that said n equals 20 times 12 is wrong. Okay. So it should be 10 times 12. It's only been 10 years. Okay, but that was the answer that was correct. Everything was right. Okay. So when it says every month for 10 years, it means 10 times 12, not what it says, which is 20 times 12. Okay. I have to go in and check that problem, why it says that. Any other questions on this? That was the quiz. Okay. Devon's already left. You guys have any other questions about this? Want to try another quiz? Let's see what another quiz looks like. I think there's a different question for question 5. You know what? Let me just edit it. I'll know when I edit the test. Okay, so there's 5 questions in the first one, like what is it? But you already know that's a multiple choice. There's only 4 questions there. There's 12 lines from the table, from the, how did this happen? And then there's 12 different ones of these. So what do they look like? Oh, so look, there's several different types of questions there. There's fill in the blank one, the A, B, and C that we did. There's also this one is. So this one's super easy because this one's just do it. It doesn't say you have to do substitutions. So you could literally just put that into Desmos and get an answer. So those are easy. What else were there? Looks like another one we just fill it in. Yeah, this is another definite interval. Okay, so you either have the one where you have to do the A, B, or C, or you just have a regular integral. Integral ones are fine. And the last one, there's only one question. That question I just showed you is every question. They're all the same. But they're different years, 2005, 2015, 2010, 2020. Okay. So this quiz should be easy and you should have it done by next week. Anything else that we need to go over? Okay, so you'll finish that quiz next week and then I start reviewing. Let me just take a look at mod 11, 12, and 13 because I don't think there's anything in there but review stuff. Correct your midterm, watch some videos. There's a conclusion discussion, which is just your feedback. It's not, I don't know if it's open yet. No practice final. This is a review for the integrals test. That we don't have an integrals test, we have a project. So I'll talk about the project next week. And what else? I think that's it. Anything else anybody wants to do before I let you go? Because I don't, y'all came today. It's nice to see you. So I have a talk tomorrow. You know this? So anyway, I have a talk on, so the title of my talk is here, I'll show it to you. I'm not going to go through it, but this is, the title of my talk is, oh, it's downloaded, hold on. These are the slides for my talk, I put it here. The best price for lemonade. No one's good, by the way, I have the worst time slot. I'm in the last time slot in the smallest room. So I'm pretty sure they think no one's going to come and that would be okay with me. But I looked at some of the other people's slides and they were awful. So I shouldn't say that. I'm being recorded now. So hold on, let's just kill that. They weren't awful. They were very busy. If I want to be said, this is about as busy a slide as I want to put in a PowerPoint, but they had some slides that were just so much reading, like they were just literally taking abstracts out of, and I think that's a mistake. So, hold on for a second.